Okay, so the other day we started geometric sequence. So that's when you are multiplying it by the same thing every time. So it wouldn't go up because you're multiplying the previous term. What you're multiplying it by is the same, the common ratio, but it's not always the same increase amount if you looked at it. So this is an example is compound interest. So now we're going to look at applications of this, the geometric. So compound interest is an example of a geometric sequence, and so is reducing balance decay is an example of this. All right, so if we have a look here, it says we've got the finding the nth term formula there. So that instead of having to go on our calculator, you know how we just put the rule in and we click. If I said what's term 100, you don't want to be sitting there for 100 times clicking enter. So this is a rule that you can generate it quicker. So Tn, so n just means the number term you want. So say you wanted, so down there in the example, you want the 15th term. So if you look at it, you're going to say T15. So you've said that n is 15. Now, if you look at that formula, we need to write what A is, and A is the first term that you've been given, which here, what's the first term? So A is 3. Good. And then if you look at R's the common ratio that it is going up by. So remember, if we don't know what the ratio is, remember we did this last lesson, you can go T2 divided by T1 will give you the ratio. So if you go 6 divided by 3, it's 2. Okay, so we know what R is now, so we can work out the 15th term. We're going to say 3 times 2 to the power of, now n is 15 in our case, minus 1. So what we're actually doing on our calculator is 3 times 2 to the power of 14. And if you do that on your calculator, you should get 49152. So you could answer that T15 is 49152. Okay? So that's the nth term. When they ask you to get the nth term, they mean because the formula is written like that, Tn. Okay, back there. Oh, sorry. So let's do the next one. So when you are finding the rule for the common ratio given a percentage, so say instead of saying we're going to times every term by 2, we might say it's going to decrease by 20% every time, or we might say it increases by 20%. So can you see when you're trying to find that R value, so if you think back to that rule on the other page, remember we had Tn equals A times, and we're going to do the R. So this is what we're looking at. Yeah, so R to the power of n, whatever. Okay, so this is how we can work out R if it's a reduction. So say we might put a little example there so you can know. So say it was reducing by 5%. What you're going to times it by, it'll be 1 minus 5 over 100, which equals 0.95. So what you're actually timesing it by is 0.95. Okay, that's your reduction. We'll do another one. Say we were going to increase every term by 25%. You add it. So you'd have 1 plus 25 over 100. So it'll equal, what you'd be timesing every time by is 1.25. All right, so let's do this example they've given you. State to 2 decimal places the first 4 terms in each of these geometric sequences for the changes given. Okay, so number A, or the first one, it starts at 200 and each new term is 4% less than the previous term. So you know that A equals 200, and now you're trying to work out what the R is, yeah? So you've got, it's a reduction, so it'd be 1 minus 4 over 100. So you're going to times it by 0.96. So then, because they just want your first 4 terms in the calculator, so remember you can type, remember when we do type 200, press enter, and we get this. And then remember, if you just go and write times, and you're going to times it by 0.96, you should see answer comes up, yeah? You press enter, you'll get 192, keep pressing enter now, we'll get 184.32 and 176.95. I'll just pause it and do it on the calculator and show you. Right, so there, I just dropped that in on how we did it. So yeah, we saw though when we did it and we first pressed times, that originally said answer. Remember that? So just remember that.